1, 2, hello, hello, there's my other light. All right, we're gonna take a couple minutes to get going here. I'm gonna turn off the streams coming back at me. If you can't hear me, let me know. It looks like it should be working. Otherwise, I'll say hello. I apologize in advance for the stuffy nose. Stuffy nose. I have a toddler at home who's in daycare. So that's the way the world works. Hello, Beata. Hello, DCD. Hello, Sam. I'll be delayed probably putting the notes up like I was last weekend. I got to get out of here right after this. And it's PyCascades weekend, which I'm getting excited about. I was just trying to figure out what Pythonistas I know that'll be there. And saw some folks on Mastodon that I'm excited to meet up with. Hey, Randall. I'll say it again later too, but if you're at PyCascades or if you're ever in Seattle and you want to meet up, reach out to me so that we can coordinate. My schedule is going to be a little bit busy. Well, not busy. I will not be there at the whole thing, which is weird for me, but that's the way it's going to be. USB time. Hey, y'all. Hi, Tyeth. Hello, Mira. USB host today. Yeah, I figured we'd work on some USB host Featherwing stuff in particular. I've got some refactoring I think I need to do. It's been a kind of a nightmare, honestly, but I'll get into that. I do want to do my talk. I know we saw it last week too, but what better place or way to practice than to do it live here in the deep dive. So that's kind of my plan. Actually, since I'm talking about the plan, let's start from the beginning. Hello, everyone. My name is Scott. I work on CircuitPython for Adafruit. CircuitPython is an open source software company about open source software company based in New York. I live in Seattle. I work remotely for them. They do open source. They fund open source software, and they write open source software, and they also create open source hardware. And I worked for them for 8 years. It'll be 8 years in August, something like that, on CircuitPython, which is a version of Python, a programming language designed for microcontrollers. Here's an example. This is a can feather. So this is an RP2040 microcontroller right here. It's a little tiny computer. It runs at 133 megahertz or so. And it's got like 128 kilobytes of RAM, all kind of self-contained, under $1 for the chip itself. The boards are about $20-ish usually, although they vary a little bit based on kind of all the other features and stuff that is around the microcontroller chip. So Adafruit pays me to get CircuitPython running on all sorts of cool little boards like this. If you want to support me, you can support me through Adafruit because they pay me to do this by going to adafruit.com and purchasing some of the hardware there. That's CircuitPython, that's Adafruit. I'm Scott. I go by Tannewt online. I have a 2-year-old who goes to daycare, and I have a cold from him. It's like day 2. I had a sore throat, and now I've got the stuffy nose, and pretty sure I kept my partner up sleeping last night. I think she like tried to like jostle me awake because I was snoring. And after that, I was like, okay, I can't lay on my back. It's worse when I'm on my back. So that's life with a toddler. I'm going to PyCascades this weekend. So this is what I was talking about. Deep dives are usually 2 hours, and that's what I'm shooting for today, where I talk about kind of what I've been working on and also answer any questions folks have. So I'm happy to entertain questions and do my best to answer them. My kind of 2 topics for today is I want to do a practice run on my talk. Tyeth asked how long the slot is. The slot is 25 minutes, and that's on Sunday. You can buy virtual tickets to PyCascades if you want to watch it live, but I'm pretty sure they post it after the fact. And of course, you'll see kind of exactly what I'm going to show on Sunday as well. So that was one topic, the PyCascade stuff. it's pretty much done. I did a few tweaks, but nothing major. And maybe I'll do a little more, but I don't know. I'm kind of over it. Put enough time into it. And then I'm planning on doing, I've been working on getting the USB Host Featherwing support into CircuitPython. So what is that? Well, it's a separate chip that you can plug a USB device or hub into. So here I have, this is called a Featherwing doubler. So I have the USB Host Featherwing. There's a Max 3421E on here that talks to, is a USB host. And then you can plug a Feather here microcontroller to control the USB bus that you create with this Featherwing. So the really cool thing about this is that for chips that either have one native USB that we're already using for a device or don't have it at all, you'll still be able to do USB host, which is really cool. And Mira says, I have the USB host 2.0 board for Arduino, but I got intimidated by the source code in GitHub. So it's probably using this same chip, which is what I'm actually adding support for in CircuitPython. So you could do it without Arduino in the future. So those are the two topics. Let me say some hellos, and then we'll decide which of the two I want to do first. I definitely want to do a practice run. So it may be better to do that first before I get sucked into debugging and refactoring. So hello DJ Devon 3, hello Deshipu, hello C Grover, and hello Ask Patrick W. Thanks all for joining. Hello, I said hi to Beata, but again, and then hello Mira as well. Sorry for teasing the USB host stuff, but I think maybe what I should do is just take the next 25 or so minutes and just run through the presentation I was working on last week as a, I think my partner might, I might give her the talk as well, but she probably will have suggestions. And at this, like I said, at this point, I'm like, I don't really care to tweak it too much anymore. DCD agrees, says get your priorities, do the talk practice first. All right, let's do that. So let me move my secret browser window out of the way. And sorry if I'm sniffly or super sniffly. I don't feel that bad, and I don't have a fever. And I also did do a COVID test this morning, so I know it's not COVID. I used our last one, so I probably actually should order more. I'm still here for it. Great, Mira. Awesome. Okay. I know I don't have the slides yet. What I will do is I am going to try to get the let's see, how's that? Oh, got to give permissions again for sharing. There we go. Wayland has more screen sharing permissions than usually. Nothing like a co-working stream. Heck yeah. I'm in this office by myself. I do have some really cool neighbors in this building, but they're not even programmers. They're all sorts of things. Yeah, we should probably defer questions for 25 minutes. So if anybody has questions, do it now before I get started. That's a good idea. Thanks, DCD. Let's see if I'm fitting into this. I've designed it to be, it's 1280 by 720 is what the slides are. Any questions before I get going? I usually, what I'll do is I'll take voice notes as well. That's how I time myself, because then I actually have a copy of it too. I was planning on going to PyCascades tomorrow with the toddler, but I read the email from them yesterday, and it said that it is masks required inside. So Ari's getting better at wearing a mask, but he's not perfect. So I was like, oh, I guess I can't take him. Plus, he's got this cold but he's further along than I am. Who gets to play the part of the one person who insists on asking a question in the middle? Yeah, we'll see. We'll see how the audience should be pretty chummy, hopefully. Just had our COVID boosters inserted this morning. We're conference season ready. Nice. I got one in the fall, and I probably won't get one again until this fall. I was thinking that I had I had COVID a year ago. So I also got boosted that way as well. DJ Devon 3, will you be taking a tripod camera and making sure you have your own recording? I will not, because this video will be just as good. Like I could cut this out. I could cut this version out for later, or sometimes sometimes I could do a screen recording and do it. I can make my own if I need it. I don't need to do it live. Having an audience really, to me, doesn't add a lot. In fact, I don't actually plan on going to any presentations. For me, like, these conferences are about like catching up with people and seeing them, not sitting and watching a talk. That's not what it's for. Which I have to remember is that usually when I'm speaking, I'm thinking more about the people that are going to watch it on YouTube later than the folks in the room. Okay, let me pull up my voice memo. And we'll get started because I don't see any other questions. It's funny, it like tries to come up with a clever name for where you took it, and I'm like in this building with all these small businesses, so it was like some flower shop or something that it said that like where my voice memo had been taken. Okay. Bad bar nails, that's what it says. Okay. Hello everyone, my name is Scott. This is Cutting the USB Cord Wirelessly Programming CircuitPython. So first, before we begin, I won't remove the chat windows, this is just a backup. My name is Scott, I work for Adafruit. Adafruit does open source hardware and software. Based out in New York City, I work remotely here from Seattle. You want to find me online, I go by TanNewt. It's like randomly generated in the 90s, but nice and unique. And that's how you can find me online. So let me introduce you to CircuitPython, and then we'll get into exactly how we're going to cut the cord. So this is a clue. This is just one example of what CircuitPython runs on. So here you can see a screen. It's similar to, I was going to find my Pi badge. I got to do that. Similar to this Pi badge that I've got. And on the back, we have some key things that I want to point out. I'm not going to cover everything. But here's a USB cable or a USB plug, so you can plug into it. There's a microcontroller here. It's the NRF52840. It's, tens of megahertz and 100 or 200, 250 or so kilobytes of RAM. And then there's also an antenna here. So this microcontroller chip can do Bluetooth low energy, which is called BLE. I will call BLE. So this is an example of something that can run CircuitPython. So how do you do that? Well, to get CircuitPython for a particular board, you go to circuitpython.org. Up on the top left, you have a downloads link. So once you click that, you're going to get a whole bunch of boards there. And the top ones are sorted by popularity, and then kind of after that, it's alphabetical. These Picos are pretty popular. So if you want to find a clue, you type in clue. You get a list of one. So far, we've only done one clue design. So we're going to click that one, and then we're going to go to the boards page. And now we can download a UF2 file. So UF2 is a version of the code. You could think of it kind of like this python.exe or CPython binary that you run. What you're doing is you're putting that on the other computer, the other device, the microcontroller, and the UF2 bootloader and the format help you do that. So we're going to download that, and now what we're going to do is we're going to plug in our USB cable into our hub, and then we're going to plug it into the clue, and we're going to press the reset button twice, a double tap that will get us into the bootloader. The bootloader's job is to kind of like move that initial binary onto the device itself. This one's super nice. The UF2 one is super nice in that it presents a a USB drive. So once you've double tapped and you've got a green NeoPixel, or the single color LED will like do a slow fade up and down when your USB is active. What you can do is you can drag your UF2 file that you just downloaded onto clue boot in this case. So it'll be a USB drive that ends in boot. Now, this file system is fake. You copy the file over and it knows how to lay it out in the memory of that device. Once you do that, or after that file is completed successfully, even if it shows you an error, it will reset automatically once it's gotten all the data. And on there, you'll get a code.py. This is where your code lives inside the device, on the device. All human readable. CircuitPython takes care of all of the execution for you on the device itself. So you got the CircuitPy drive now. It switched from boot to CircuitPy, and you also have code.py. Now, if you double tap code.py, it'll open in your favorite text editor. I use Sublime Text, and we ship with a default version that says Hello World on most boards. It might be blank otherwise. So Hello World. And if you want to see the output, what you need to do is you need to connect over the serial link. So serial is like text characters back and forth. And so I like to use TO. So I've opened the terminal window, and in the terminal window, I like TO. One thing that's nice, pro tip for Linux users, is you can do dev serial by ID, and then it uses the USB name, which is really handy. The nice thing about TO is that it will reconnect if you like unplug and plug it back in, which is really nice. So you can see here that like I plugged it in and then had to connect to it again. So that was really nice. If you are connected but don't see anything, you can Control-C to stop the user code, and then Control-D to reload it. So that's what I do here. I Controlled-C and then just pressed any key to get into the repl. This is where you could type in things just as if you had run Python on your command line in a desktop computer. But it's running on the device itself, not on your computer. If you do Control-D, then it will auto-reload, and you can see Hello World appears here. So now if we go back to our Sublime Text, we can replace world with PyCascades. And it's unsaved now, but once we save, we can see that on the right-hand side, it automatically reran our user code. Now it says Hello PyCascades. So that's a brief tour of CircuitPython and sneakily the workflow of how you use a USB connection to do a number of things that I think that are required to be able to program CircuitPython or a device like this. So what makes a workflow? Let's take a step back. First, we installed CircuitPython, so that's kind of one piece of the puzzle. Once you have that, how do you get file system access? In this case, we use that to edit code, but we may actually want to like copy over libraries or images or sound files or things like that. So we need general like file system operations, not just editing a single file. And then also, how do we get our print output? How do we do a serial connection? Those are kind of like the core components of what makes up, in my mind, a workflow. So how do we take this like one example that works really well with USB and kind of expand it and cut that cord? So a couple things to consider. First, what devices are we trying to program from? Desktop, laptop, phone, tablet are different challenges. Desktop, laptop, obviously USB is quite good for, but phones support will vary a lot. And then also, how do you have connectivity to the device? USB is one way, a cable is one way, but also wireless is really interesting. So that's what we're talking about today. So here's kind of the three core connectivity options that we have currently. And I've added notes here about like what microcontroller families support those, but I won't go into details. I showed you USB already. I showed you the USB workflow. And then today I'm going to cover briefly our Bluetooth Low Energy or BLE workflow, which is really good for kind of ad hoc connections to your devices. You don't have to worry about being on the same Wi-Fi or anything. Once you're paired, you're kind of connected for life, or hopefully life. One example is like my watch here is running CircuitPython and it's connected to my phone over Bluetooth. So good for on the go. Especially with iOS and Android that have varying levels of like like USB support, but also just like, why would you want a USB cable plugged into your phone all the time? And then Wi-Fi is also good for being wireless, but it's kind of more of a stationary thing because you have this like third device called like the router usually, where like both your phone or your computer are talking to the Wi-Fi router, and then the Wi-Fi router is also talking to one or more devices. And that's really where it excels, I think, is like you're at home, you have 5 sensors around your house, like you can just discover them all and you can edit them, and that's great. So when talking about these workflows, I'm going to kind of cover the status of them. And we already showed USB, so this is kind of, there's one axis is like the connectivity and then what you want to do, and whether the API supports it, and whether we have a solution for desktop and mobile, or like desktop, laptop are in the same category, but then mobile is like phone and tablet. So if you're using a desktop and a regular computer, using USB is really good. We have well-defined USB APIs for file system access and serial access. Upgrading is great, especially with the UF2 bootloader. You can kind of do that from like Android and maybe iOS, but it's kind of sketchy. So that's why I said there's partial support there. I want to cover Wi-Fi and BLE, and I'm going to kind of do this in like Wi-Fi in the desktop and then BLE in mobile devices. But the desktop solution and the mobile solutions work kind of across as well. So like the mobile solution I show will also work with Wi-Fi, and the Wi-Fi solution I show can work with BLE as well. All right, so the first step to a workflow is how do you install it? And right now our answer is pretty much you still have to use a USB cable to install originally. There is a caveat that like the boot drive showing requires kind of more support from a device than if you just had a serial link to the microcontroller. So I'm going to show you kind of the process that you could follow in order to install it without the boot device. Now this example actually uses the boot device still, but we'll see that. BLE, there's like my watch has a specific way of loading code, and that works, but there's like no great standard, at least that we've like fully supported for CircuitPython. And then Wi-Fi, same. There's not a clear way to like get it in a certain mode and loading particular code. Okay, so if you want to install without boot, the place to go is circuitpython.org. So you can go to circuitpython.org. I have this other code that I'm looking at, or other board that I'm looking at. This is an ESP32S2 Feather. It's a Wi-Fi device instead of a BLE device. There are other chips in the family that don't have full USB support. This does, but if the board that you have doesn't, then this workflow will work for you there too. So if you scroll down, you'll see now there's, for the ESP chips, there's an open installer link. You can click that and it says, oh, oops, you're in Firefox. Oh, darn. This doesn't work in Firefox because Firefox doesn't currently have web serial support. So this is a way of talking to a physical, like a wired serial link that the host OS enables the browser to talk to. So Chrome is your best bet for more exploratory connectivity mechanics. So web serial, web Bluetooth, for example. Okay, so we're in Chromium now, and we have a couple options. We could do a full install. We could also just update our Wi-Fi credentials. This is super handy if you're don't want to do everything, for example. But we're going to do the full install, and it tells you a warning that it's new and experimental, and has some caveats about like make sure you're using a data USB cable, because in this flow you're doing serial over USB still to do the installation, but not necessarily with the boot drive. So what you can do is you click connect, and then I can never capture this window, but the browser will pop out a window with all the serial devices that you can talk to, and it grants permission. You might have issues if it's opened by another program. So like if you have TIO running already, you're going to have to make sure and stop that. This can happen with that. But once you're connected, up there you can see in the tab there's kind of a like neat logo that shows that it's connected to serial. It gives you a warning that everything's going to be overwritten, and then once you do that, it will erase the flash, which is what stores stuff, and then it writes a new bin. After that, it then copies to the boot drive. I think this is, yeah. So browsers can also access full folders. So you select the boot drive, and then it'll pop up a native dialog, select the Feather or the whatever boot drive there, and then the browser will confirm that you want to allow the site to have access to that like subtree of files. So you do that, and then it downloads the UF2 there, and you do the same thing with CircuitPy if you're able to, and now you can put in your Wi-Fi credentials. So this is like step 1.5, which is like CircuitPython is installed, but you haven't necessarily gotten connected to it, or in Wi-Fi's case, connected it to your router, right? So when you do the install, that's when we expect you to kind of provision the SSID and the password so that it gets on your network as well. So you add it there, and then it says complete, great. And now what happened is that on your CircuitPy drive, there's now a settings.toml that has these specific keys. If it starts with CircuitPy_, that means CircuitPy is going to use it. CircuitPython's going to use it. SSID and password will auto-connect when the device starts to that Wi-Fi network. And then if you have web API passwords set, it will start an MDNS server, which is great for discovery. I'll show that to you in just a second. And then it will also start an HTTP server that has a REST API so that you can interact with things. Okay, so to get there, what you do is you go to http no-s circuitpython.local. That triggers your browser and then your OS to do a kind of a discovery process on your network. So broadcast something out that says, hey, is anybody circuitpython.local? And then all of these things can reply back to say that, oh, that's me. Here's my IP address. This is what's commonly used for like discovering printers on your network and like other like Apple TV devices. They use the same MDNS mechanic. Okay, so once you do that, you'll go to a web page, but you'll notice that there was actually a redirect for circuitpython.local to the specific devices.local. So all CircuitPython devices on your network will respond to circuitpython.local. And then those devices will then redirect you to their specific one so you get to the specific device. Furthermore, what it will do is the devices can run a slightly different discovery mechanic to find all CircuitPython devices. And when it does that, every device will list all of the other ones that it's found when you hit this landing page. So it makes it really easy for you to click like circuitpython.local, you get any of the devices, and then from that page you can pick the one that you actually want to talk to. So we're going to do that, and we'll notice that the URL changed, and also you'll see that the device listed is a different one. So now we're on our ESP32S2 that we loaded, and we want to click the file edit portion. We have a weak password protection on that, so don't use any special password. It's all HTTP. It's like transparently sent over your local network. This doesn't hit the internet, but still be aware that it's really just a little bar to prevent easy misuse or malicious use. So put your password in here. I like to use like hello or password, and no username. Once you sign in, you'll get a list of your files. You can see we have code.py here. But because we're on USB, it's actually preventing us from writing or editing anything. So what you have to do is then eject in your OS, and that will tell CircuitPython that like, hey, the OS over USB is not going to change anything. All right. So you can once you reload, you can hit edit. And once you hit edit, you get this super bare bones editor that will work even if you don't have internet. If you do have internet, though, you can go to code.circuitpython.org, and that we have an in-browser editor that is actually capable of editing over USB and Bluetooth as well in Chrome for Bluetooth. USB, I think, works in Firefox. Anyway, it'll tell you. Wi-Fi is a little tricky because you actually have to be on the domain of the device. So you can go to the device's name /code /code/, and it'll pull the same editor up, but kind of hosted or downloaded from the like HTML stub on the device itself, so that the domain's right. You can do that, and you can then open a file, select code.py, and hit save and run. it will do the same thing. It'll open up a split screen with the serial output. You can see hello world here. I've also changed the left-hand side to PyCascades, so once I hit save, it now shows up on the right-hand side again. So this is all the steps that I was talking about for the workflow, but this is a desktop and Wi-Fi kind of combination to that, and it should work over BLE as well. Should. Okay, so let's do this for mobile. How am I doing on time? 18 minutes. Okay, so now let's do the Bluetooth and mobile combination, because I think that's like quite popular and powerful. So the Bluetooth in particular has this tricky bit, and on mobile, that there's no kind of standard API for file manipulation and no standard serial kind of link as well. So you have to kind of rely on apps that do particular things. So Adafruit's funded and created a few apps to do these things. FileGlider, in the app itself, allows you to access the file system and manipulate it and do basic editing, but it also hooks up into the OS's notion of files, which I'll show you in just a little bit, but that allows other apps to just edit a file that is kind of like, it doesn't have to worry about how to like manipulate it. It's available on Android and iOS, but I'll show you the iOS version here. So click Glider, and now you have a list of devices that you've already connected to. But if you want to connect to a new device, like the Clue that I showed earlier, when you do the double tap, you got to do a slower double tap. So what happens is like the bootloader starts, and then CircuitPython starts, and it'll do a yellow flash, which is safe mode, and then after that it will do a blue flash. So you reset during the blue flash, and then that resets the whole device, but there's some state that it can tell when it gets back there. And that will be in a kind of pairing discoverable mode. Now it is like less powerful than normal, so you have to make sure you're real close to the device. And that's meant as another little hurdle to just like prevent somebody from across the room being able to connect. Okay, so back to Glider, you'll see that there's a new device discovered. You click that, and then you can hit pair. This is kind of like giving it additional permissions. Thanks, Dexter. Once you give that extra permissions, you can now list your file system. You can see code.py. I can load code.py. This is kind of just what I saw. And then if you go back to your Files app, now you can hit, you'll see there's a Glider location. Once you hit Glider, you can list your devices. And once you click your device, you can list the files in the Files app, except for the fact that there's a bug and it doesn't work right now, unfortunately. So you'll see that's a kind of a theme of these newer ways of editing CircuitPython. So, but that's FileGlider. Let's talk about the serial side of things for a second. We have Bluefruit Connect, which is kind of a generic Swiss Army knife for Bluetooth connectivity to devices. One of the things it can do is a serial connection. And so you can hit Bluefruit Connect. It's going to give you a bigger list of devices. But if you find yours, you can click it. It'll have a CircuitPython option. Once you click CircuitPython, you have this kind of blank screen syndrome again, because it doesn't necessarily know that you've connected to the serial. So what you have to do is if you click the text box, you can Control-C it and then Control-D again to kind of trigger CircuitPython, like, hey, I'm here, send me stuff. So here you could see that I interrupted some other code that was running. Last up, and I'm running out of time, so I'm breezing through it. PyLeap is an app that we have that's kind of like meant to get you over the blank code.py syndrome. So Adafruit has a learning system where there's a lot of tutorials and guides. PyLeap's goal is to get a whole kind of project onto your device for you, and it lets you browse it. You'll notice this is a GIF, and that's because I actually ran into a bug when I was using it too, which I think is close to fixed, or at least our dev is working on it. So keep an eye on that as well. Okay, so that's an overview of kind of the different combinations of programming CircuitPython and doing it wirelessly. If you want to know more about how this works under the hood, my first pointer is to the workflow documentation page, where it will go into more details about like how all of those different functions are achieved over different connectivity standards. My goal has been to like kind of meet people where they're at. So like use, like if we're doing BLE, we're going to do it the BLE way. If we're using like network, we're going to do it the network rest in my mind way. So BLE does like, there's a standard serial service called Nordic UART service. We do that, but we change the unique IDs just so that the user can also do a serial service. And then we've created a custom file transfer service that's meant to be pretty easy to implement. Web workflow, there's MDNS for discovery, like I talked about. That's the .local and kind of finding other CircuitPython devices. There's an HTTP API for file access. And then there's also a web socket that you can connect to for serial access. If you want to help us out, here's the app source links. I'll have a link in just a moment to the slides if you want to click through to these, but they are all open source. That's kind of Adafruit's MO. So where are we at? So here's our full matrix. Installing and upgrading is not really supported wirelessly over Wi-Fi and BLE, but USB is pretty solid for that, and provisioning. Print output over Wi-Fi on mobile is kind of like, I'm not sure how that would work, but generally we have that. Although if I'm to be honest, a lot of this is still really new, not used by a lot of folks, and pretty buggy. So love to have your help. Love to see folks use those APIs under the hood. That's why I've broken those out here. They should be relatively more stable than the apps, but you know, if they don't get used, they can rot. So would love your help to use these ways of programming CircuitPython. Please report issues. We do want to make sure that they work well and that they continue to work well. And if you have ideas about tooling and apps and ideas, we'd love to see those. So that's wirelessly programming CircuitPython. Thanks to Antonio and Trevor for working on the mobile apps. Thanks to Melissa for all of that cool code.circuitpython.org stuff. And also thanks to Liz, Blitzcity DIY, for testing all of this stuff and really finding lots of issues. Here's the links, circuitpython.org, and the link to the slides if you want to click through some of these other links. That's it. 2520. Bad bar nails. All right. Dexter, thanks for the time codes. UF2 does have OTA update support. It's just not in CircuitPython yet. I don't know. How does he? I know that there's the TinyUF2 bootloader has 2 partitions. Move the app links to the end after where your roadmap slide is, so you have more time. Just the app source, I do think that is in a little bit of a weird position. I agree with that. And I did hear from the code of conduct folks. You think it's after this bug slide is where it should go? I think that makes sense from the like call to action. Yeah, okay, that'll work. Taya says smashed it. DJ Devin3, we don't have bugs in CircuitPython, just happy accidents. Yeah, right. Ask Patrick W says, okay, yeah, move the links. Mark says, good job, this reminds me I have to play with BLE and Wi-Fi workflows more as I have devices that could use both. See, that is exactly why I wanted to give this talk. Last week, Timon was on and he was like, I didn't know you could do that. So like, that's why I, like this talk is, that's my goal with this talk. My goal is to be like, hey, we have this, you should use it, you should try it. I know it doesn't quite work all the time, but we want to make sure, we want to get it to the point that it does. And we can't really get it to the point that it does until we have people regularly using it. Thanks, Timon. Definitely know more now. Yeah, I mean, I know it's the same as last week. But I wanted to practice it one more time. I feel pretty good about it. Like, even the first time I ran through it, I think I ran through it on... I went over it last week, but I didn't run through it. And then I had, like, we had a meeting that ended at 4, and I had half an hour meeting before show and tell on Wednesday, and I ran it through in that slot, and I was like, yeah, that worked pretty well. The timing was pretty good, so yeah, I feel pretty good about it. PyLeap looks exactly what people need. I'm afraid of leaving people to fend for themselves with a lot of the stuff. Yeah, totally. And there's more integration we could do where we have the project bundles now with on the Learn system. Like maybe if you're on Chrome, we could actually like download it straight to your device. And Timon missed half of it last week. Nice. Beata says, once upon a time there was OBEX for file transfer. Linux still supports it. Apple couldn't say. OBEX. I did look, but I never really saw anything. It was far more refined than last week. Excellent presentation and representation of how CircuitPython really is. Great, thank you. I did practice it on Wednesday. That was not my first run through, although that might be my last run through. I feel pretty confident with it. I'm not worried. You know, I was like 20 seconds over time. I will probably talk faster. Talk faster and forget stuff on Sunday. It's just how it goes. Hopefully I feel better. We'll see. Felt like you got it. Sweet. All right. Well, that's it. I don't even really need to think I need to re-render it because I'll just do it from the browser here. And oh, I guess I should push it because I'm going to do it from a different computer. Okay, let's re-render the PDF. I have it. Last time I did the PDF, but I failed to push it. Have a phone, watch clock timer or something. You can see if they do not have one for you. I do the same thing actually that I just did. I usually just voice record myself even when I'm giving the presentation. Let's just use it as my timer, right? Like once you're recording, it tells you how much time it's been recording. Okay. Tweaks. Did I figure out how to make the PDF smaller? I did not. Instead, I set up LFS, which is large files, which is a Git thing. So it actually doesn't store the PDF in the Git repository when it gets that big. It stores like a placeholder. But then there's like some code, there's Git LFS that will just like transparently get the file for you anyway. So I just set that up instead. The other reason to do it earlier is like getting a little more tired of talking after talking for 25 minutes. All right. Should we switch brains? Okay. So USB Host Featherwing. Did I close my browser? I did. Darn. One giant JPEG and then zoom in on text. I'm really not a fan of JPEG because of the artifacts that you get with like around text. JPEG's designed for pictures, like photos, not graphics. Like, I think it's Vanguard. Like, it looks like they made this better, but this image is like pretty well, like pretty poorly like edited. It has all these artifacts and stuff. I was like, ugh. Yeah, JPEG. Good night, Dishipu. Thanks for stopping by. Sleep tight. Okay. So this is the Adafruit USB Host Featherwing, which I showed earlier, and what I've been trying to get support in CircuitPython for. I wanted to do this in the fall when the product came out, but as folks know, I was busy with my mom being sick. So it's been a minute that this product's been out, but we don't support it in CircuitPython, and it is something that we want to do. So I've been working on it. It turns out it's harder than I thought it would be at the start. And I can go into why today. So like I said, the idea is that we can take pretty much any feather, plug it next to this Host Featherwing, or the Host Featherwing can go on top, it doesn't matter. The nice thing about having it on the doubler like they have in this picture and I have here is that you still have access to the top of the feather itself. Yeah, so this is a separate chip called the MAX3421E that is connected over a SPI link to the host microcontroller. So it uses like SPI transactions to do register reads and writes. And TinyUSB's added support, and TAC, like this demo is an Arduino example, so TAC's gotten it working in Arduino. And so I'm coming along and trying to get it working in CircuitPython. DJ Devon3 says, I didn't know it wasn't supported in CircuitPython yet. Oh yeah, it's not. There's an issue that has been open for a while that Dan and I were going through issues and be like, oh yeah, you should assign that to me. I'm working on it. And then David points out that there's a top secret QtPy version coming out as well, which is like a smaller form factor board that has the same chip on it. It actually is really popular. Adafruit's not the only one to do it. So if you look at like SparkFun USB Host, I think it's USB Host, like this USB-C Host Shield has the same chip. So like this is kind of the only chip that I know of that kind of works this way, where you can have it connect, like have it from another microcontroller. So it's not new. The chip's not new. It's kind of been around for a while, but our desire to like make products with it and support it is relatively new. So what does it take to support it in CircuitPython? Well, TinyUSB added support, and in CircuitPython, what I'm doing is I'm adding a new, I have a code.py right here. So this is what you do in CircuitPython. This is my test demo, which have I shown this on the deep dive yet? I don't remember. I know I did PyCascades all last weekend, or last week. I don't know if I did it at all. I've shown this on show and tell, the last 3 show and tells, but I don't know if I've talked about this for a deep dive at all. Anyway, so what you'll do is you have your board SPI, and then you also need a chip select and an interrupt line. So the interrupt line is a separate line that says like, hey, you need to do something with me. It's like very similar to what happens internally. It's just each show and tell improved progress. Yes, it did. I've been making progress, but it's been more of a fight than I really care to do. It's been a lot trickier than I thought it would be originally. And it's largely because of this SPI bus, right? So SPI buses are shared buses where they have data in, or data out, data in, and a clock. And then what you have is you have a chip select line, and you can have multiple chip select lines. So you can connect the data lines and the clock line to more than one chip, and then you only have one chip select line active at a time. That's great, except it makes it really complicated when you have this, for example, where it asserts an interrupt, says, hey, you got to talk to me, but you might actually be talking to something else already. And that's kind of the rub of why it's been kind of like tricky for me to do. And yeah, so what you do is you set it up as a host chip. You just leave it there, which I was thinking about whether I like that design or not. So this, and then the import USB, this is the host API. and it's implementing a subset of the PyUSB API that you would have on like Linux or Mac. So you can say, I want to find the devices. You say for device. Yeah, so this is like, if you saw my show and tells, this is the code that's running in my demos on show and tell. So you print finding devices, and then you iterate over device that you find when you do USB core find all. And then a device has some properties on it, like its vendor ID, its product ID, and then its manufacturer and product names. So these are strings. And they're fetched, the manufacturer and product ID are fetched on demand, whereas ID and vendor ID and product ID are kind of fetched on when they're connected. DJ Devin 3 says, this must have been what you meant in dev chat where you're talking about spy working as an interrupt, which sounds wacky. Yes, this is what I was talking about. So I've been using like the reference implementation. So to look at TinyUSB, you can go into examples, host, bear API. This is very similar to kind of what my CircuitPython's doing, where bear example, board init, task, that's how I think of it in my brain, TinyUSB host task, you call repeatedly over and over, and then you'll get some callbacks from TinyUSB, and you want to print, when a device is plugged in, you want to print information about it. There's more stuff here, but you'll notice that like ID, vendor, and product are in here. And then it has to do separate calls for the manufacturer and product. That's what my example code will trigger to. Except there's configuration descriptor stuff. I don't know what it's doing. HID stuff. Yeah, I don't know what that's doing. So this example is kind of like the TinyUSB side of things, and then there's board support. So if you go in hardware, BSP, and then the last one I was doing was RP2040. So if you look in here in family.c, this is shared kind of like amongst all RP2040 example code. So this is not kind of part of the library itself, but it's part of the examples in my brain. So CircuitPython doesn't use this code, but it's code that we're looking at as an example of how to use it. So here's how they get everything set up. And you can see here that it calls, if you have it configured to use the MAX3421, which is that chip on these boards, it will call that init on it. And MAX341 init is actually just down here. So it's doing like interrupt chip select and interrupt pin setup, and then setting up a SPI bus, right? So they're not sharing a SPI bus, they're just making one dedicated to it, which is part of why it's been so tricky. It's because like TinyUSB didn't really fully account for like the idea that it could be shared. So I fully expect that we're gonna find more bugs before it's like really solid. One thing that's also interesting is that this interrupt line is actually hooked up to an interrupt. So when the line falls down, like you'll actually get a CPU interrupt that runs this interrupt handler, which it checks to make sure that it's the right thing that caused it, and then it runs this TinyUSB host interrupt handler thing. This is pretty standard for this is pretty standard for how TinyUSB works, and usually it's okay. But the gotcha with the Mac stuff is that it still does SPI transactions, whereas it usually would just do transactions to the internal USB, and that's okay because it's not going to be on a shared bus. But with SPI, it is. DCD says, so how are you sharing the shared serial port resource? Right, so this is the way TinyUSB is doing it. So in order to implement, so there's 3 API calls that you have to do 3 API calls, and really kind of 4 in order to like in CircuitPython that I had to do so that TinyUSB works with the Macs. So first I have to give it a way of setting the chip select line, either high or low. I have to give it an API for disabling or enabling the interrupt pin. So it's already set up, but it might want to turn it off and on so it doesn't get interrupted. And then lastly, a SPI transfer API. So this is the API that TinyUSB will call in order to do the SPI transaction. And so this example is just using the Pico SDK directly, and it's not sharing its SPI initialization at all. It's specific to that. So now let's pull up CircuitPython. So ideally what we would do is we would say in shared, well, let me just show you. So in shared bindings, there's now a max 3421E module, which I have not documented yet, so I should fix. This is one thing I could do on the stream in the next hour, is I actually need to go over this stuff because it's not right. I forget what I copied it from. I think 4wire, actually. So this needs to be updated. I haven't updated it yet. I've updated this stuff. So you create it with a SPI bus, you give it a chip select line and an IRQ line as well, and you can change the baud rate. And then it calls into this common HAL construct, which is like totally common CircuitPython stuff. It has a dinit object. So this is something that I asked TAC to add, was the ability to actually turn it off. Like so many vendor SDKs don't have this ability, but in CircuitPython, we actually turn everything off between VM runs so that you kind of start with the same state. So we have a dinit, and you may have seen discussion of finalizers. So here we're doing the allocation with m new object with finalizer. And what that does is, like, if I set the variable name to this object and I say delete that variable name, what it will do is it say like, okay, you can no longer use this thing. And then when you do a GC collection, it'll come along and delete it fully. And when it deletes it fully, it will actually call what's this like dunder double underscore delete method will be called on the object to give it a chance to kind of like fully shut down before the memory goes away. So that's what finalizer does. And all of those finalizers also run at the end of the VM. So you're kind of like assured that you'll be dinit. In CircuitPython, like Python, the language doesn't tell you when that dunder delete will be called. So in CircuitPython, we have this convention of having a dinit function as well that you can call, and it will happen immediately when you do it. So you know when exactly that deinitialization process will go. And then your dinit will just check to see like if it's already been done. It just doesn't do anything. So that's kind of the API, and it's a little, I don't know. I'm waffling on this, like, should you have to pass this to something else to say that you're doing USB host or not? Did you say that just the SPI serial was shared, or could the interrupt line potentially be shared? I think yes, sometimes you have the interrupt line shared. I think it would be okay to have, like, usually the way you share an interrupt line is that, like, it's pulled high and everybody sets it to 0 as they need it. So yeah, in theory, you could share the interrupt line as well. And then you just have to make sure that you would have to check all of the devices that share the interrupt line in that case. I guess I'm assuming that it's not shared. In this API, I'm taking it in as a pin. So if I wanted it to be shared, I could do it as a digital in-out or something, but I'm just doing it as a pin. So the way I'm implementing it, you can't share it, but in theory you could. The reality is the way the code's now, you're not going to be able to hook two up. There's not a lot of reason to hook two up because you can actually have a hub. If you want to connect multiple devices, you don't need multiple Featherwings. You would just do a USB hub. So on the doubler, which wires go between the two boards? Does the learn guide come later? I think there is a learn guide already, but the doubler just connects the boards in the same way as if you just stack them on top of each other. So it's kind of like the default setup. It's kind of the default setup that D9 and D10 are IRQ and CS. But you can cut it if you want to change it, I think is what it is. So that's the kind of like, how do you initialize it from CircuitPython? And I got to fix these docs. These docs are wrong. And then the implementation side happens in shared module, because a lot of this is kind of standard stuff. So in shared module, you can see I have some leftover ESP logging that I will rip out eventually. But like, it's not working perfectly yet. So you construct it, you say, oh, if the host is already initialized, you just raise an error. If you already have one active, you also raise an error. Will it work with the USB host feather? No. So the USB host feather is set up to use the RP2040's core and PIO to do the host stuff. And I should, yeah, that's how it works. But the reason it can't work with the host feather is because of, right now, TinyUSB only allows you to have one host implementation active. So the way that TinyUSB switches between host implementations is like they all implement the same functions with the same names. So if we enable Max 3421, we can't have host support from anything else. So I don't think we'll ever, like the IMX RTs, well, maybe. The ones with 2 USB ports will probably just use the native USB host, but maybe on the lower ones that only have one, then like we could have the device stack for the native one and the host stack for the Max. That would be okay. But we can't have the PIO USB stack next to the Max. PIO USB host stack next to the Max 3421 host stack currently. It's not structured like that. So no. My goal has been to get it working on the reason I want to add RP2040 support is that there's the DVI featherwing, or the DVI feather. So this is the RP2040 with the DVI output. So the DVI output's really pretty hungry too. It also takes the second core. So the reality is you're not going to do PIO USB, but you could do a USB host featherwing. So I want to turn on Max 3421 support in the DVI feather. It's my goal, so that you can do DVI output and do USB host, which I think would be cool. Okay, so we're actually just using digital in-outs for our chip select and our IRQ to initialize it, and then we have a separate init IRQ call that is port specific. So this, we don't have an internal API currently for like call this function when this pin changes. So that's why there is some port specific implementation that has to go on here. And it's like surprisingly difficult. Although I think what I'm going to do is factor some stuff out. So once we do that, we're good. We can turn on the TinyUSB host stack and init it. We just init at 2. I set a variable name somewhere. I'm going to have to look with this fresh eyes next week. My goal is to get this checked in by the end of next week. And then we have a deinitted check. We just set bus to null if it is. And then in deinit, we deinit the interrupt. We deinit the TinyUSB host stack. And then we reset the pins. Actually, I wonder if we should deinit. Yeah, that's probably better. Instead of calling reset, we deinit it, since we're using digital in-out to create it. And then and we don't need .pin. And then we're good. We set the bus to null, and we set the active shared value to null as well. Ah, yep. Jepler did a RP2040 USB host and a Feather DVI to create a CPM emulator, but it was Arduino. Oh, and he must have had like a serial link between the two. Okay, so here's this API that we have to implement for TinyUSB. So chip select API, and it says active or not active. Now, this is where we do bus locking, but we actually don't have any way right now to tell TinyUSB that we can't lock the bus. So we kind of like, what I'm finding is we have to preemptively like not call the things that assume that they can lock the bus. Like there's separate bus locking internal to TinyUSB as well for this. It's just, Tack and I are working on it still. Anyway, so this is what it does. When you want to set the chip select, we double check that the SPI bus is still initted. There's a caveat here that when finalizers run, there's no specific order. So the finalizer for the Max3421E might run after the SPI bus is already torn down or deinitted. So you got to check for that. If it's active, you want to make sure that you haven't already locked the bus. You try to lock the bus, and if you can't do it, you're done, and you don't store that you have the lock. Otherwise, you did manage to grab it. You configure for your baud rate, and then you set your chip select low. And then if you're doing the reverse, if you're not active and you've locked it, then you can set the chip select back and unlock the bus. That's pretty straightforward. Transfer API, you check the SPI bus again, and then depending on what buffers are set, you can call read, write, or transfer. Transfer is almost that, except we have separate APIs so that you can provide like what the byte is that if you're reading, what byte gets transmitted as you do that. And then there's this API for enabling and disabling, and it calls out to the port specific version after checking that the SPI bus is in it. So what we have to implement per port is pretty simple. It's all just this interrupt stuff, but it's like surprisingly complicated because the interrupt could happen at a time, well, on Espressif you have free RTOS, and with free RTOS you have a bunch of tasks. And the pin interrupt, so let's just start there. I did get it working. I showed that on show and tell. So to find port-specific implementation stuff, you go ports, Espressif, common HAL, and then the module name. So here's the Max3421E. So we actually have to create on Espressif a separate free RTOS task that runs the TinyUSB task, because that's the way TinyUSB's worked if it's in free RTOS mode, is that the TinyUSB host task will good question. So Timon asks, does CircuitPython have any form of concurrent execution at the moment? Like when it's not run by an RTOS. So yes, so in Espressif we have free RTOS tasks. We do have some concurrency, but the concurrency that you have to worry about is twofold and kind of for CircuitPython itself. One is interrupts. So interrupts can still happen at any time that you haven't turned interrupts off, which you will see. And then second is we have this notion of background tasks, which are like small chunks of work that we want to run. It's kind of like a coroutine, I guess, but it runs on the same stack as like the main CircuitPython thread. And you'll see calls like, if we look in common HAL bus.io SPI and transfer, you'll see that like while we wait for the transactions to finish, we call this run background. We do this run background tasks macro. So we have a linked list of like function and data pairs that we call in as background tasks. So for everything except Espressif, like that's when your TinyUSB device task and host tasks will run, is when an interrupt happens. Say like the USB device says, hey, I need to run stuff. It'll run the interrupt handler TinyUSB stuff immediately. That will queue up stuff that gets run in the task function instead. So on free RTOS, there's a separate actual task. On everything else, there's just that interrupt will also queue a background task that CircuitPython will run later. Whenever this happens, and this happens also, so you'll see it in common HAL implementations where it's going to take a little while to respond. So like SPI's relatively slow, and then they also happen every opcode of the VM. Like every time the VM goes around its loop, it also will run any background tasks. Are those guaranteed to run in a certain interval, or is it best effort whenever you're free? It's kind of like a bit of both. It's not guaranteed to run quickly, but things stop working well if they're not. So yeah, you kind of have to manually decide if your execution's running long enough. You have to add this run background tasks thing. And it'll do it for you. Which is another gotcha. So because SPI calls it, and Espressif, so going back to Espressif's implementation, and it's even weird in TinyUSB. So you have a new host task, that's okay, fine. But you also do. So I just piggyback on this init IRQ call to actually create the host task. I don't want to create the task if I don't need it, so I'm just doing it when the init IRQ is done. So I create a new FreeRTOS task. It allocates stack memory and blah, 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 so I might fail. And then I install the interrupt service. And if that fails, I delete the task because I don't actually need it. I failed. And then I add this handler. And this handler gets called actually by a different task. And this different task, even in the doc, says like, this task doesn't have much stack. And turns out that like doing all the SPI stuff kind of like makes the stack long enough that it gets too long. So even TinyUSB, they have a signal that goes from the actual interrupt to another task that then calls the interrupt handler for TinyUSB. Like the goal is to call this TinyUSB host interrupt handler with your instance number when an interrupt happens. But on ESP, you don't have enough stack space to actually do it from your interrupt itself. And so I'm using the background tasks method to schedule the interrupt handler call in the CircuitPython task. So on the real interrupt handler, we say add this callback to the interrupt callback. So that's CircuitPython's internals. And then I also disable the interrupt for now because the interrupt is on the low level. So there's a period, it goes low when it needs work, and then it's going to be low until you get back to it, and then it'll go away. But if you miss that falling edge, you might actually like never get to the work. So instead I have it say like, if it's ever low, then you need to do this, blah, blah, blah. So on the actual interrupt handler, add a thing that might try to run the real interrupt handler. But ignore it if it's not initialized. Now try to lock the SPI bus, because we actually know that this TinyUSB interrupt handler is going to try to do SPI stuff. and it's not going to be smart if it can't get the SPI bus. So only do that thing if we know that it can actually add it. If it doesn't, so try to lock the SPI bus. If you're not able to, then add this function again to the list of things. So like the next time run background tasks happens, it'll run again. And then if it was able to lock, you unlock it so that this interrupt handler thing can actually use it. And then once that's done, you can turn the interrupt back on. Which is like dancing around like free RTOS and like making sure everything coordinates well. But I think this is actually what I need to do in all ports. So I've been having a lot of trouble getting it running on the RP2040, and I think it's kind of the same reason. Someone says, but sounds like you could eventually use some concept of threading behind the scenes eventually. Sounds quite complicated to maintain things that have real-time-ish needs like that, especially if you ever have multiple things like that. Yes. Yeah, and I was doing this work, and I don't know if folks saw, but maybe it was on the internal Slack, but I just said, like, I kind of feel like at some point we're going to adopt free RTOS for everything. I'll tell you, I worry about managing all of the different stacks and their stack sizes to do that. The nice thing about this background task thing is like you don't need separate stacks. You just do a little piece of work on the existing stack. So I think we'll get there, but yeah. When you disable the interrupt, should that be before adding the interrupt task to avoid low-level retriggering? Well, I know when I do this background callback add, I know for a fact that the background callback won't happen. Do I know that? I don't know if I actually know that. On non-ESP ports, I know that because an interrupt is happening in the same stack as the current CircuitPython task. And then yeah, it's complicated. I posted a thing that says, I posted the thing like concurrency is complicated, and this is exactly why. Like people want like interrupts and concurrency in CircuitPython, and they're just like, it just gets so much more complicated. Someone says, I'm holding myself back to suggest Zephyr. I know Zephyr's on our radar. It's one option. The problem with Zephyr is it does way more than what we need, and it has way more tools than we need. Like all we need is an RTOS. We don't need a HAL. We want a Bluetooth stack, but like we don't need a build system. We don't need a configuration system. Like, yeah. No, you can cut it down pretty well. I don't have the background. But I'm going to the Zephyr Developer Summit, not next week, but the week after. So we're working on it. I think Jeff, Dan, and I have kind of assumed that we're going to do it at some point. And I think one thing that's really going to push us that direction is as more boards come out with multiple cores, like the RP2040 is an example. Like it just makes more and more sense to use an RTOS to manage multiple cores. So I think we'll get there. It just might be like CircuitPython 15. I don't know. We're definitely going that direction. Like we're evolving there. Like CircuitPython 9 introduced this idea that we have a heap that lives longer than the VM's heap. Like that's new to CircuitPython, and that's going to have some impact with CircuitPython and implementations in CircuitPython that are evolving us more towards that way. And it, when we have free RTOS with Espressif, that's really nice. The other problem with Zephyr is that we support a lot of different vendors, and they're not necessarily supported across all of the things that we do. We interface with a lot of different SDKs. ARM mixed with RISC-V is really common with lots of upcoming chips, which I find interesting. Yeah, that is interesting. This is why why I have a interest in build systems. But yeah, multi-arch sounds like even more complicated. Yeah, I'm curious to see where they're at. Like, I'm gonna meet up with the TSC folks, and like I realized it's been over 2 years since I've been on the TSC, which is the technical steering committee of Zephyr. So I had pretty deep knowledge or insight into like the leadership org. And the reason I got there is because it's pay for play. Like you pay enough to be part of the Zephyr Foundation, and you get a vote on the technical steering committee. But yeah, I'm curious to see where they're at, because it's been a minute since I've been in those meetings. Okay, but I think this is basically what I need to do for all things, because I was still, on the RP2040, I was still having this problem that the interrupt can happen even when I'm doing something else. Loads more vendors join too. I'm in particular interested in Espressif, because I really like their approach for like the nimble and free RTOS. So yeah, we're doing a lot with Espressif, so that matters. Okay, so I think what I want to do today, and I still have this stupid cursor bug, but I want to factor this out. I want to factor out this kind of delayed interrupt handler call, because I think I need it. I think I essentially need it in all of the ports, because I'm like having trouble getting the RP2040 working. So I think I need to actually just make it standard. Load up a 700 megahertz RISC-V 64 or turn on an ARM core. Nice. 256 meg RAM version of the Milk 5 Duos have been shipped to me, waiting for them to get to the Costa Rica. Neat. Buying the hardware is the easy part. The software support's the hard part. That's why I make the big bucks. Software support's hard. Okay, so I'm going to factor this out. I'm going to say, I wonder if we just make this. Okay. Cut. I'm going to move this from here to the shared module, because I want to do it all the time. It's just going to make it simpler. And like this delaying stuff is not port specific. Ports must call this their interrupt handler. Okay. And now we copy this and we'll put it in here. Bus is free. And I guess we could make this, yeah, let's make this self to be clear. We might have to put a like super thin wrapper around it for the expressive version, but that's okay. Okay, so now I've factored it out, and it's doing the interrupt handler in self, but I know that the RP2040 version is not that nice. It doesn't, it's interesting, you can do a callback, but you can't give it one piece of data that it also gives to you, so you have to manage it yourself, which is a pain. Let's see, I want to make board. Sorry, I know that I moved this off for a second. S3 PS RAM. It's like quiet. I'm not in my directory. Get myself in expressive mode. Just spotted max instances set to 2 for max 31 and super. Does that mean dual featherwing support? That's not quite what the define is. It's the instance number. I don't know where it's used at all. But TinyUSB has this notion of root hub port. In theory, because you have like more than one, you could have more than one. Oh, so I did. TinyUSB doesn't allow you to have multiple implementations of the host stuff, but it does give you this RH port parameter in case you have multiple instances of it. So I guess there is this world where we could, in theory, have 2 max chips. Maybe. I don't know. It's kind of complicated. Yeah, so this is what I was worried about, is that it's complaining that the pointer is incompatible. It should be void pointer instead of that. So what I'm going to do is just add a super simple static void. I thought we got rid of all these capitalized statics, but maybe that's a MicroPython thing that we didn't do yet. Interrupt wrapper void star, and then we call this max, whatever this is. Just casting it. Like, we know what it is. I know you don't know. I really wish they'd fix that cursor thing for me, but they're ignoring me. I let them close it. That was my problem. I let them close the issue and then I reopened it and nobody paid attention to it. Interrupt. Oh, I called it handler in one case and wrapper in the other. Okay, so should I test this? I kind of don't feel like it. I gotta test this more anyway. I think what I want to do is actually get it. I'm gonna do the RP2040 version. I'll just make sure it compiles. But I want to see if I can get RP2040 working. Conflicting types. Ah, okay. I didn't change the type here. Yeah, see here, you see how it's getting RH port? That is the like, what instance of it are you thinking? Dual featherwing support. I'm not making that work. There's no really reason that you want to do it. Is that true? You're going to be limited by your SPI width, your SPI bandwidth anyway. Which I guess you could use 2 SPI buses. Just use a hub. Just use a hub. If you want multiple USB devices, just use the hub. That way you get power as well. Oh, and then I need to import. I would like to get to the world where my Clang D will help me out. Oh, I need to do the address of those. They're not the pointers. Oh, you know what? I wanted to find my Pi badge too. What am I doing? Maybe if RP2040 works, I'll have time to do Pi badge. Because it's a masks required, I was thinking what I should do is just put my picture on my Pi badge. How does it even support multiple devices as in multiple of these chips? I'm not trying to do that. In theory, you could by like reading the RH port and mapping back to an object, but I'm not doing that. RH port should be carried through, but I don't know if it's really tested at all. Okay, let's do a new tab. And I want to try the Raspberry Pi side. And I should push this too, just so it's up on GitHub. I just think if I get sicker and I have to work from home, I can like SSH in and push things to GitHub, but generally it's better to just have it backed up. Okay, so in here, you can see I'm doing this max int handler again. And it is a little annoying that like the add raw IRQ handler here doesn't set anything. Oh, and yeah, that makes sense. We're gonna need another wrapper here. And then USB background schedule. RH short for an RH port. I think it's root hub. Root hub? Yeah. And yes, background scheduler we want in our shared implementation too. Background scheduling on ESP won't do anything. It'll be fine. Like it'll run the background thing again, but the background thing doesn't do anything. Background callback add in our handler. Okay, we do want that too. Okay, we do want that. So we want max. And then we want to give it active max. Oh, come on. Missing cursor is so frustrating. Interrupt wrapper, and we have it in multiple places. Okay. You might want to handle more endpoints than are possible with a single IC, but that's a pretty involved application. Yeah, that's true. I hadn't thought about that. Okay, just clean. Where would my Pi badge be? Not only my Pi badge, but my... I bet it's in... Pi badges are SANDs, right? I bet it's just in my SAND box. SAND 51. I bet that's where it is. USB background schedule. I think that's just... Probably should have taken our allergy pill this morning. It's in here. There we go. All right. Let's... Where's my USB-C cord? Here's one. I have 2 USB-C cords over here, and I have 2 micro USB ones. That seems to get me by. Okay, this is the DVI firmware. Oh, didn't mount anything? Was I not holding boot cell? There we go. We have more basic requirements for USB host than that many endpoints right now. Okay. Finding devices. Let's plug in my test keyboard. Heyo! And is it still going? It is. That's good news. Now let's try the Control-C test. And, oh, it's still responding. See, there's debug prints, but that's okay. Yes, I will take that. Sweet. Okay. So that's working too. And I think I want to just do Nordic the same way. I thought Nordic was working well, but I wonder what I did. We renamed this folder recently. If it seems weird to you, it's called that. It was renamed. So it doesn't know. It doesn't know active whatever either. That's so annoying. Yeah, I'll tell you, I had the opposite of that earlier this week because of this stuff. I think I do need to do the same thing. I'm basically guarding the TinyUSB stack from getting a case where the SPI is busy. By moving the host interrupt handler into that background task and then checking to make sure that they can lock, I'm protecting TinyUSB from that. Okay. I do want to do that. I have like, this is part of my challenge. Like, how many different copies of this one file do I have open? That's part of the problem with that naming convention. So instead of doing these two things, I'm going to do the max interrupt handler with active. And I have to keep track of which one the active one is. Okay. And I could guard more, but kind of lazy, kind of done, kind of Friday. I'll push it all and then. So there. That's what I was testing on. Arms throwing the keyboard across the room in frustration. No, that wasn't my reaction. I was pretty much like, I'm done. I'm going home. Or like, what other fun things could I work on? I haven't played video games this week. That's kind of been raising up in priority. Like I need some easier wins. Multiple definitions of active. Let's just call this static. I'm just gonna make sure it compiles. There we go. I've been doing ESP so long, I'm just like, I build anything else, I'm like, whoa, that went so fast. RP2040 plus airlift featherwing plus USB host featherwing would work. Why? You want Wi-Fi and DVI and a USB host? Like, I really don't like the airlift stuff. Let me be honest. If you need Wi-Fi, use an ESP chip, is my opinion. Okay. I should clean this up, but I don't feel like it. So let's get our merge, Sublime merge going. I'm just gonna commit it, push it. I gotta clean it up next week, but I don't feel like it. And I do actually want to take a quick peek and see if I can't find my TinyUSB update. I think I want that. I'll double check. But taking this stuff out makes sense. I change that. Oh, this is a tricky one. This dash Linux on here was what was causing a linker error. So I do want that. I do want that. I don't want this. I don't actually want it on the regular Feather RP2040. This is also why I like this a lot. Oh, I turned off the spy background things. I should test it with that. But I think it'll work now. I certainly don't want to commit it. And then there's this one remove IRQ. And the spy and the Raspberry Pi. Too many wings and you get pin conflicts. That's true too. Did you see the AT commands for matter setup made sense, but also my heart sank? No. Checkpoint on success. True. True, true, true. Checkpoint on success, and also when you just are about to leave. Okay, that makes sense. That makes sense. All right. And then I just want to switch to TinyUSB and just say git log. I think that's right. Like that's origin master. That's really new, like yesterday new. I think that's right. We're on the leading edge of TinyUSB for all this stuff. as I code attack and be like, this doesn't work. Have you thought about this? Okay. Works on RP2 as well. Okay, so if you want to try it over the weekend, let me get the formatting right. I don't even remember. It's a nice thing about auto formatters. This will be pushed to my Macs. Let's see, why is it? What else do I have that's... No, we don't need this stuff. All right, so if you want to do that, it's pushed. Did I push my presentation? I think I did. Yeah. Okay, great. We have 15 minutes. If folks have questions, put them in the chats. I'm going to just grab my CMD51 box and see if I can find my. I used to have just a Pi badge with a lanyard for conferences, and I need to dust that off, or at least find it for this one. I found Pi badges, but no lanyard, which I was hoping to find. Ah. I zap everything. I found the Pi badges, but apparently I took it off the lanyard. So I'm not exactly sure where the lanyards ended up. But since I'm here, let's do Pi badge. Oh, I don't have that many LiPo batteries anymore. I've got 3 tiny ones, a 105, and 105. I have 3 105s, and I've got a giant one. I have a 2000. I did actually take some of these and put them, oh look, I reset the microcontroller. I have a static problem in here, for sure. And I have in my, oh, here we go. Here we go. This is what I need, a 350. I don't remember what I was using it for, but I'll use that. I have in my DigiKey cart a anti-static mat. And like, I gotta take care of it, because I think it does actually go through like the USB. Like, because I constantly am resetting boards now. So I need to get my static under control. I've had the humidifier on all day and I'm still having static issues. So if you have pointers for static, anti-static stuff, let me know. Okay. I don't know the difference between, I guess one of these is a Pi badge Lite. I have this Pi badge and I have this Pi badge. This one's got tape on the back, so that one must be the one that I've used before. Looks like it's stuck on there pretty well. This tape is not sticky anymore. Actually, let's see. Where does the battery go? There it is. This is probably the battery that was on here before. And there's a switch. Uh-oh. It's only showing a white screen. I'm glad I tested it before I worried too much about it. I've not been by it in a while, and you and the team have done a lot of cool stuff. PyLeap is an example. You're going to do great at PyCascades. Thanks. Thanks, Patrick. The new salt batteries have left and wearables. Seattle and static seems impossible. I don't know, like this building is definitely, I was thinking about maybe it's the flooring. Like the flooring may not be dissipating at all. But I touched this desk that I have here, but I think it actually does go through like the USB that's sitting on it. Because like I reset the micro. That's why TO reset. So I'm gonna do something about it. Conductive ground post less on your feet can always do quite a lot to reduce issues. Mag tag. No static issues. Snowden doesn't. It was like rain. It rained last night, and I still have issues here. Okay, this display doesn't work anymore. Oh, I saw Celeste briefly. This one might be in rough shape. Wonder if this one works anymore. I might have messed up my... That's what being on a lanyard will do. Like it gets it briefly. I mean, maybe it's just a bug. All right, where's my micro USB now? Here's another C. Here's a micro. Okay, put my mic back on. Okay, we have bootloader. Badge boot. What version of CircuitPython do you think is on here? Doesn't control C. Oh, I'm in the bootloader. That's why. All right, before I bootload it, let's see what version of CircuitPython's running on there. I thought it was funny that it had industries in it. Huh, is CircuitPython not happy? What? It's still in the bootloader? I don't see the CircuitPy drive coming up. Huh? I don't know what's on here. Well, there's a CircuitPy drive, but it's because I have this one plugged in. Tricky. Maybe CircuitPython just got hosed. Like I thought I saw it doing something quickly. PyBadge airlift, that never happened. 903. Downloads. Modified time. finished. Will it come up? I should just try this other one. This other one, the screen's falling off though. Like somehow the screen's not, like the reflector behind the light is not on. Hey, that one started up. I don't get anything on the screen still, it's just white. All right, well that was a nice idea. Yeah, it blips and then it goes away. I don't know. I am not nice to my micros. That's part of it. Let's see what this one does. Anti-static wrist strap clipped to one of the wires that plugs into a ground pin socket of a surge protector. That's a good idea. It crossed my mind to just wrist strap myself, but I don't think I'd be, I don't know. I'd rather do something where I just, in this area, I'm okay. Come on. I need toddler fingers. Hey, that starts up. Oh, it's my Python version of Celeste. Do people know that I made this? I ported the original like Lua Pico 8 Celeste to CircuitPython. Maybe I'll just bring this. I won't even update it. Oh, I died. Can you see it? Oh, there's a double jump, isn't there? Is that right? I thought there was a double jump. Yeah, this works pretty well. I thought it was a double jump. Yeah, that's fun. Maybe I'll tape this down. Cool, I'll just bring that. All right. Oh, Lopta says 2000 milliamp hour, yep. Was it this week Adafruit showed an anti-static wrist strap new products? Now I suddenly want a PyBadge. Huh. Dilute fabric softener in a sprayed on floor helps prevent static from shoes. New carpet can be terrible in a video arcade. This is why I know about this. I think I generate it by scooching off my chair is usually when it's the problem. Yeah, Desco, I was looking at the floor mat for Desco thing. Yeah, okay. Hey, there's guesses. Wireless workflow on MagTag. We didn't have CircuitPython 001 for much long. I think I have a prototype Feather M0 Express that is red running CircuitPython less than 1. It might be in that giant box of PCBs. I don't remember exactly where it is. Second camera for overhead views. Oh. I have this side camera too. I just didn't switch to it. Oh, the iFixit anti-static wrist strap. I will look at that. I will probably make an order next week. So yeah, definitely with the humidifier. All right. Well, thank you, everybody. I'm going to get out of here. It is 4 o'clock. I'm going to look for my lanyard a bit more, and then I'm going to get out of here. I'll just bring this. This Celeste demo is pretty cool, in my opinion. So I'll just bring that. And I should charge it. I think this battery's charged, but I don't know. Does the PyBadge have a charging circuit? Yes, it does. Okay, great. And I have my double stick tape right here. Last minute things to do. Before I go to, like, there's a PyCascades social tonight that I'm hoping to go to. Oops. I wonder how well this Celeste demo works now. I should get a couple more 350s like this. All right, Scatterbrain Scott is done for the night and the weekend. Thank you all for being here. It's a pleasure. Thank you for humoring me with all this slide stuff. I know it's not programming, but it's all part of what I do for Adafruit and what they pay me to do. So thanks so much. It's been a pleasure. If you want to find me, you can find me on the Discord server. So you can go to the URL adafru.it/discord. That will get you where we kind of work kind of like this sort of discussion, but all week long. Not generally there on non-work times. So heads up with that. PyCascades this weekend, you can attend virtually if you buy a virtual ticket if you like. If you're going to be there in person, please message me on Discord or something like that so that we can coordinate. I'm not going to be there a lot, so I want to make sure and meet up with folks if they're there. What else? If you want to support me, you could go to adafruit.com, purchase some stuff like the Pi badge here, and help me out. And help Adafruit out. They help me out. They pay me to do all this stuff, so thanks to them. Thanks to everybody who buys stuff from Adafruit. You make all of this open source hardware and software possible. I should be here next week, but the week after I will not. So I will coordinate with Foamy Guy about doing a deep dive 2 weeks from today. Assuming I'm healthy, or healthy enough. Okay, have a great weekend, everybody. We'll do a little window cam, and then I'm going to get out of here. And you can see my light. This light here. You just won't have as many APIs in CircuitPython before 1.0. And there was a period where all of the I/O APIs were like one module, but we decided not to do that before the 1.0 release. All right, have a great weekend, everybody.